let's just first set some expectation what this seminar is not going to be about, which were two things we will not say. First of all is we will not say AI is bad, because honestly, also I think automation is very good. We should automate all mundane tasks, and it makes us more efficient. It's also good for accessibility, for example, for transcription, right? And we will also then see, though, that knowledge is not really separate from skills. So if you have a solid foundation, you can really supercharge yourself with AI. And here just a short example. If you, for example, have named entity recognition and you need to label this 2 sentences as a human, easy to do. If you have millions of texts, you might not want to do that in human hours, right? And then if, for example, some conditions change and you need to redo some things, it would be even more work. So perfect task for AI also, right? And then the other thing we're not going to talk about is ethics, because, yeah, let's be honest, it's like when you're wearing, for example, cheap clothes, you don't really think about it, and if people cared, they wouldn't use it. So, but I just want to shortly digress to this essay, which is from, because I think it's an interesting perspective of these data workers that usually remain invisible. So I just shortly want to show this. It's about the emotional labor behind those data workers. And just to say what data workers are, they sometimes are seen as the more ethical alternative to like just scraping training data, right, without asking for permission. And in Michael's case, for example, he was impersonating actually a chatbot, and his customers expected him to be a chatbot. And it was actually for romantic conversations, but he didn't know beforehand what he was going into in that job. And then he just changed between different characters and picked up where his colleagues left off, and he had to reach certain message quotas and user engagement. The problem with this job, though, was that it needed constant emotional performance of fake emotions, right? He had to be someone he wasn't, he had to pretend to feel things he wasn't, or show affection he didn't have. So it was not only questionable because he lied to his customers, but also because it impacted the real connections he had with his close people, right? The line became blurred between what was his real emotions and what not, which made him more distant. And he said even some colleagues of his were like struggling to keep these relationships. And the other problem of this was like he was closely monitored. For each answer he gave, it needed to be good enough. And they also checked how the humans on the other side reacted, because of course the goal of this process was not just to keep tricking those customers forever, but to use this conversation data then to train more conversational AI to imitate emotions. But yeah, enough about that. Let's go about what the seminar is really about, and like why we should avoid actually uncritical adoption of AI for knowledge work. Because as we will see, if you depend too much on it, you're actually impacting key cognitive functions like critical thinking, your memory storage, and also problem solving. And just short to say what exactly is knowledge work defined, it's basically work that is based on knowledge and expertise. So examples are software engineers, or also architects, designers, physicians, and even or lawyers. And now let's come to some statements that we will learn about why this is the case. Like our brain needs knowledge, even though we have this possibility to cognitively offload with a Google search or just asking for a prompt, right? And we also can only learn when we have some friction. To give you a low friction example, for example, we want to be productive. So we're watching this tutorial video while we're eating dinner, right? And the thing is, we might think we are learning during this process, but since the cost of doing this is so low, we're usually just consuming literally just food and that video, right? And that this is also because the brain actually can create pointers to information, so you know where to find this information, and it might make you think that you know this information, but you actually don't. The knowledge is missing. And we will also see why this where and what is neurologically very different. So let's first go to a bit basics of neuroscience. Is the engrams, which are basically the physical traces that you can observe of memories when you use, for example, color markers, right? And whenever you learn or experience something, a group of neurons activate and they can form stronger and stronger connections. And these engrams are scattered around the brain. And in the second picture on the right, you see these clusters of engrams. So when you retrieve a memory, clusters of engrams activate together. And together, these engrams actually, because they're not really like working files on a computer, even though they're the physical trace of memory, they're more like organized into existing mental frameworks, which are called schemata. To give you an example of such a schema, for example, a dog, it's basically, your schema of a dog is basically based on your past experience of common details. Like, for example, it has fur, it barks. Most of the time, it has 4 legs, right? And then when you used to recall information, the same neurons reactivated that were originally activating when you first had that experience. So it's important to know that we reconstruct our memories. We don't instantly get the correct memory, right? We're filling missing data in these schemata that are grouped together. And also what is interesting to know, so this small subset of engrams can trigger an entire network of schematas because it's actually performing pattern completion since everything is interconnected. And yeah, since AI usually gives you pointers, it's not knowledge. And also because these are completely different cues and engrams that will be activated when you know where something is and when you know what something is. So to retrieve actual information, you need an existing schema in your brain about this fact. So if you always let ChatGPT do it, you don't have that information. And let's shortly show how the memory consolidation works. It's actually in 2 phases. That is first local strengthening when you keep getting an information. And then there is later a system distribution over networks. While the first one can take a few hours, this one can take actually up to many years. And it also happens with a selective process with tagging, which is based on novelty, surprise, rewards, which sounds similar to also how AI does it, right? And I'm not trying to not go into too many biological details, but it's basically the hippocampus that is responsible for this, that replays then these tagged memories later while you're resting. So it's most effective during sleep, for example, and then it redistributes this memory slowly to further regions in the brain. But first they start usually in the hippocampus. But we see later that's not always the case. And then when you have, after you experience something or get a new memory and you reflect afterwards, it can enhance your memory or this tagging process, which also means if you're solving a problem and you directly take your handy or mobile phone or you're asking ChatGPT for the next prompt, it might happen that you're not even tagging the process and then you will never consolidate the memory about the problem you just solved because you didn't give yourself enough time. So let's shortly show it on a concept of, like Python, for example. You have first, when you learn about Python, you also have extra information that you don't really need, like the snake and also snake scales, right? And these local neurons get strengthened, have this extra clutter included. Then when you keep using and encountering and retrieving this concept, you slowly start to prune the wrong connections like the snake scales because they don't have to do with the Python programming language, right? And you will get more details about Python itself in your associations. And then in the end, you will have just the elegant, effective gist of what you exactly need for the Python programming language. And when this happens and it doesn't consolidate much further, there's actually something that happens after many, many retrievals. Then you can make links to other new concepts, which is then basically important that you can have more creative problem solving for new situations, or you're learning faster related processes when you're at this point of knowledge, and it also enriches your understanding. And basically what then happens with the schemata is that they become so tuned that it's very intuitive and automatic, the retrieval. You don't need to consciously think about, again, do I need to go left here, for example. And this transition that you see that happens actually between the 2 memory systems of the brain, which is on the left, the declarative one. It's the blue parts because it's a completely different neural circuit, and the red one for the procedural one. The declarative one is mainly the hippocampus, and the procedural one is actually in the reverse circuits, but also mainly in the basal ganglia. And the difference between those 2 memories is the first one, you learn very fast. It's very flexible. You can get very different knowledge very fast. And even if you hear a fact once, maybe you remember it 5 minutes later also, then still. But if you don't continuously exercise it, the retrieval is very slow. You need to think about to remember it. And it's a conscious effort. For example, when you're driving home for the first time and you need to look up the directions to go left and so on. Instead, the other one is the intuitive one, but it's very slow to get. You learn very slow, get to this memory as you saw with the consolidation. So you need many repetitions, but the retrieval is very fast and automatic. So when you're driving without thinking where you have to drive anymore, and you can focus on the more complex things like looking around the street, what's happening, right? And it's usually, you can also not really verbalize it just happens. And this really helps you to also apply complex patterns across domains and recognize them. Without this procedural memory, you cannot really do that if you only have to consciously recall the facts. And yeah, what happens is the more you strengthen the connections in this declarative memory, then this order the basic language slowly takes over and automates while the activity here will lower. However, the original engrams that you had in the hippocampus are still preserved because you actually have dual access of these memories so that you can use the flexibility of the declarative memory, but the fast and intuitive and for complex patterns of the procedural one. So now what happens when you rely too heavily on an external tool? This shift from this declarative, like the fast but conscious memory, to the procedural is not happening, or even worse, you're not even memorizing it in the declarative memory. So you always have to use your slower memory. You have less resources to think about the more complex things because your working memory is actually limited and consumed by those basics. Like if you, for example, write always Java functions, not yourself, and then you need to think what's the syntax of a Java function. You're already using a lot of resources for that, which makes you slower at learning, and you can get shallow competence. But what also recently neuroscience showed is that the procedural engrams don't always take months or years. They can actually form quickly when the new info can connect to already deeply internalized knowledge. That's also the reason why you need knowledge actually to get this faster and more complex one. So if you just have awareness, this is not going to happen. And yeah, let's continue here. And yeah, short parallel to the reinforcement learning network, just to recap and what we saw. Humans need experience, feedback, and prediction error. And also the AI works here on prediction error. And with humans, the prediction error is the gap between what you expected and what happened. So when something surprises you, dopamine fires, and those connections get tagged, right? It's the tagging that you need then to later consolidate this memory. And through repeated experiences, you get more and more efficient patterns, which is the procedural memory. And if you outsource this, outsourcing bypasses these mechanisms, so you have never an expectation of a thing, and then you cannot get a prediction error. So for example, if you don't know that 3 times 4 is 12, and then you see 3 times 4 is 15, you might not question and see the error, you're not learning anything. And that's also when you take AI input and you cannot recognize the hallucinations, right? Because you don't see the mismatch. So short recap, if you don't struggle, no mismatch, you have no signal and there is no learning. And when AI short circuits your brain, you will not get this lasting knowledge and the expertise that only gets with the other memory. And then what can happen in the worst cases, you can lose the capacity to learn in that domain over time because you're slowly remembering less and less the more you rely. But yeah, let's also look into some empirical evidence of this, not just the very dry stuff, which is like this one here was an experiment basically where they had to read some information, write an essay about this information, and then different groups got a different kind of support for the revision part. So there were those, the control group with no tool involved, those that could ask a human expert for writing, those that had a writing tool, something similar like Grammarly that gives you concrete suggestions and so on, and those that were using an LLM. And basically, first of all, what they found is before, like the first version of these essays, the quality was around the same, and also the motivation of the people. So they were around around average same skill. However, those that didn't use a tool actually had the lowest motivation of them all and the lowest enjoyment in this task and the most pressure. So actually, if you get some support, it can actually help you to be more productive and more motivated, right? And the writing tool was there also the absolute opposite. They were very motivated, had low pressure, and were working a lot on themselves. However, the LLM group, the ChatGPT group, actually had the best scores. They are also outperforming those that were able to ask a human expert for help, right? And the one difference though was that they had way fewer metacognitive activities involved while revising their essay, because they were kind of stuck in a loop of prompting, writing something, short evaluation, prompting again, and not thinking about it. while those with the human expert actually had a bit richer connections because they were reading, reflecting, orienting themselves, and not just asking the expert. And yet, the writing tool, of course, those had the most evaluation and introspection, so tool design actually matters for support. And then this was another study of knowledge workers, basically, where they measured the enaction of critical thinking while using GenAI. And what they found is there were, because yes, it's in a slide, when they had higher confidence in AI on a specific task, they had less critical thinking, but it's for specific tasks, not the general confidence in AI. And the inhibitors, they found this, if they had high confidence in GenAI, they actually seem to reduce the effort required as less, even though it's the same effort, right? And motivation was another reason when they had less critical thinking, like when they had time pressure or when they felt like this is not my job. For example, somebody has to do some front-end code, but they're like way more back-end code, right? And then there is also when they didn't have the ability for something, like they lacked the domain knowledge to actually properly evaluate, so they just used the AI to help them there. And that was also another thing. Those people that had a tendency to reflect in general and a higher self-confidence actually had more critical thinking while using the LLM. So which kind of goes back to what I said at the beginning, AI can actually supercharge you, but you need these foundations. And yeah, and there was also, this paper also discussed like the shift in the critical thinking for those knowledge workers, because it's changing how we're gonna work also, right? So the information gathering became more of an information verification. You need to cross-reference, is the AI hallucinating or not? And for example, the application, instead of problem solving, they had to integrate the AI response. And then for the task execution, instead, it was more of a task stewardship, because the human still needs to keep the responsibility and accountability for what they produce. So they cannot have a one-on-one relationship with the AI. And this one here is a small study to take with a grain of salt, but I think it's interesting because it's a high stakes domain, because here shallow competence can have real consequences if doctors, like for example, do not verify the generated medical information before application, right, that they use for AI for. But yeah, let's go to the bottlenecks in software engineering. This is basically first-hand experience from practitioners who integrated AI intensively in their workflow, and also an 8-month ethnographic study of a tech company. So what they found is like you have more output, but you're also more exhausted because the individual task becomes faster, but there is also more capacity. You get more work to do, or for example, people take over tasks that they not, like for example, designers start suddenly to code and so that they were not doing before because they thought the AI is empowering them. And they were also more prompting during breaks, where they previously took breaks because it was kind of also a bit addictive, like just a quick prompt, right? And the study also found that the work was not reduced, but intensified. And another problem was that people became way more reviewers than creators, because AI-generated code needs more careful review than human-written code, since you have no narrative context of this code. Like, because if you review a human that you also know, you know his patterns, strengths, weaknesses, and so on. And also, AI can be subtly wrong. So, right, you cannot just skip parts you trust because everything can be suspect and just a slight error. And another thing is, of course, if someone has the code base in their procedural memory, they can navigate and spot the issues way faster than if they let AI create the code base and have to go search with the declarative, like step-by-step process. And yeah, also according to this study, the people had to increasingly coach colleagues that were vibe coding or complete their MRs because they were incomplete. So overall, the review time increased a lot because there were more PRs and also more sloppy PRs got created. And then tech debt also increases because when you have a solution in a very short time, it feels like inverted sunk cost, where time fixing it feels very expensive if you get the solution this fast. So they just say, yeah, I will just push it and then care about the error later. And then this is about, before AI, we had just problem solving, which is stressful. Then you code, you're actually limited by how fast you type. So you're chilling down a bit. And then you see it work have dopamine. Instead with AI, you solve a problem. So that's a bit stressful. It requires a lot of resources. You get the dopamine when it works. you've solved the next problem, right? So you're not having these breaks in between. And then there was also the dependency on AI, the problem that people, the more they relied on, the more they struggled with their own mental models of the code bases, the debugging skills and everything else. Because the procedural memory was not created anymore. The complex tasks stayed in this slow, effortful, conscious recall, right? And they also had less working memory available. And this is actually most concerning for juniors because they might never develop the necessary skills for complex reasoning. So what could we do to actually help a bit with all these issues, which is the goal is, of course, not to stop AI, which is impossible anyways, but to adopt it in a way by eroding less cognitive functions or not burning out, right? So first of all, we need to also preserve our thinking skills, right? So one of the things to do is explicit boundaries for AI-free work and also time slots where no AI. So the human takes over complex stuff like the architecture, security critical code. You should not let AI write security critical code. And the AI instead takes over the more repetitive stuff like execution and tireless repetition. And then you should also have separate this thinking from the execution time. Like don't keep looping back and forth between executing AI, shortly thinking and so on. Really just take a time frame where you put all your prompts and a time where you plan. So you have more breaks in between, allow more break in between. And also deliberately practice every day a bit without AI because to keep those engrams fresh, right? Because only then we can build expertise. And yeah, also, maybe you noticed it also if you use more AI, prompting can be a bit like gambling. Sometimes it works and then you try again and so on. And it can be addictive. There is like a good thing you could do is a free prompt rule, which is if AI doesn't give you 70% of the solution in free prompts, just write it yourself. Stop instead of trying to prompt it for hours and losing time. And also measure where AI actually helps you and where it costs you, because people think they're always more efficient, but when they, for example, get in these prompt cycles, they might actually lose way more time. And if you measure, you know actually which tasks it performs well and which tasks you should do yourself. And then another thing you can do is using back pressure. It's basically instead of directly reviewing the AI-generated code, you need those agents or AI to self-correct for diverse layers, which is, for example, type checking and linters. You can also be very strict there. And they need to reiterate until it passes. You have to keep still writing tests, right? Because that's your. And you can also do architecture enforcement. That is, for example, ArcUnit in Java, and also security scanning. And when you have these 4 steps, only then you let humans actually look at this code, because before it's anyways not good enough for you to review. And then the human can look at the business logic. Does it make sense? Is the architecture correct? And also if the approach makes sense. And another thing you can do is if the AI takes more than 3 attempts to self-correct, delegate that task maybe to the human because it might require more complex reasoning. Thank you.